Okay, here we are on page 6 of exponentials. We're just going to do the odd ones. Okay. I'm just marking these because usually I forget and I start doing them all. Number 3, write the following in the form a to the x, where a is a prime number and x is rational. Okay, so remember, prime numbers are like 1, 2, 3, 5, 7, numbers that don't have factors except for 1 in itself. Oops, not 9. Next one's like 11. All right, so cube root of 7. So we're going to have 7's already a prime number, so we could put 7 to the 1/3. Okay. This one looks like it's 16, 5th root of 16, so that would be 2 to the 4th to the 1/5 power, so that would be 2 to the 4/5. Okay. When it says x is rational, that means you're supposed to write the exponent as a fraction. 49, 7th root of 49, so that would be 7, because 49 is not prime, but 7 is. 7 squared to the 1/7 power, so that's equal to 7 to the 2/7. 1 over the 4th root of 27, so that would be 1 over 27 is 3 cubed to the 1/4 power, so that would be equal to 1 over 3 to the 3/4, and I'm going to flip that over, so I'm going to put 3 to the negative 3/4 because I'm putting it in the numerator. This one here is 1 over, it looks like the cube root of 32, so that would be 32 in a prime number base would be 2 to the 5th, so 2 to the 5th to the 1/3, so that would be equal to 2 to the 5/3, and then I would make it negative because it's in the numerator now, right? Because this is 2 to the 5/3 in the denominator, so I'm going to put it in the numerator with a negative sign. Use your calculator to find 3 to the 3/4. So let me do that. So 3 to the, I'm going to put in parentheses, 3 divided by 4. And I'll get 2.28. We should always put at least 3 significant figures. C, 2 to the negative 1/3. So that would be 2 to the negative 1/3. Should be 0.794. This one would be the 4th root of 8. So that would be 8. And then I'll put 1/4. 1.68. And then finally 1 over the cube root of 7. So it would be 1 divided by, I'm going to use parentheses around the denominator. So I'm going to put 7 cube root. .523. Okay? All right. Last one. Here I'm going to do A, C, E, G, and I. So, without using a calculator, write in simplest rational form. Okay, so 4 to the 3/2 is the same as, and I have a feeling that since it's 4, we're actually going to use the fact that 4 is a perfect square. So we're going to put the half inside, we're going to put 3 outside. 4 to the 1/2 is square root of 4, which is 2, so it's 2 cubed. So that would be 8, right? C, 16 to the 3/4. Okay, 16 is 2 to the 4th, right? So I could write that as 2 to the 4th to the 3/4 power. I can multiply those exponents together because it's an exponent to an exponent. I get 2 to the third, which is 8. What about this one? 32 can be expressed as a exponent of 2, so I could put 2 to the fifth, and then it's to the power of 2/5. So I can multiply those two together because that's an exponent to an exponent, and it's going to be 2 squared, which is 4. 9 to the negative 3/2. 9 could be expressed as 3 squared. And then to the negative 3/2, I can multiply those two together. So I'm going to get 3 to the negative 3, which is 1 over 3 cubed, which is equal to 1 over 27. Last one. 27 is 3 cubed, and so I could take that to the power of negative 4/3, and I could multiply those two together because it's an exponent to an exponent, so I get 3 to the negative 4, which is equal to 1 over 3 to the 4th, which is equal to 1 over 81. And I think that's it. Not too bad, right?